Hello everyone, I am Arpit and our group is here to present you the research paper about targeted online password guessing and underestimated threat. Now let's talk about little background about this topic. The authors are focusing on studying online password guessing, and online password guessing is when an attacker tries to guess a user's password over the internet. It can be launched against a public server by anyone at any time, and there are two main types of this. The first one is trolling, and the second one is targeted guessing. Trolling is fairly well understood, and many studies have been done for trolling guessing, but few studies have been done for targeted online password guessing. And the authors attempt to explain targeted online guessing and demonstrate that it is a very real threat that is also widely underestimated by security community. So now let's have a look at trolling guesses versus online password guessing. Trolling guesses involves using list of commonly used password in order to guess a user's password. Whereas targeted online guessing not only use list of common passwords but also uses the user's reused password and user's personal information in order to build a list of passwords to attempt to make a more educated guess and have a higher chance of success at guessing a victim's password. Now moving to what exactly is personal information. The authors define personal information is anything related to a user, and this is much more broad than PII, personal identifiable information. The author breaks classified into two types. The first one is user PII and the second one is user identification credentials. Now the picture on the left is the process of targeted online guessing attack, starting from learning users behavior and personal information to eventually hack into users account. This paper is trying to build a model or an algorithm that could carry out the targeted online guessing. Here are some of the challenges to build the model. The first one is the password choices are very different, and the second, the user's personal identifiable information is highly diverse. Third is a diversified set of transformation rules to modify password for cross-site reuse. The diversified transformation rule include insert, deletion, substring or reverse. And the last challenge is the transformation rules for password reuse are often context dependent. For example, the password contains Yahoo, it's more likely to be used on the Yahoo website. Now let's talk about types of personal information. The author defined type of PII into two further types, the type 1 and type 2. Type 1 PII is semi-public information and its role is in password is explicit. So these things are like name, birthday, phone number and social security number. And these types of PII are directly make up the building blocks of passwords. Type 2 PII on the other hand is also semi-public, but its role in passwords are implicit, meaning that these things are like gender, age and language. So they impact user behavior of password creation, but they are not directly used in the password themselves. And then user identification credential, there are two types of those as well. There is private user credential such as user's password or PIN number, which are directly used in password, and then public information like username and email address, which are also explicitly used in passwords, similarly such as they make up the building blocks of passwords. And to clarify, semi-public information is the information that is available to friends or colleagues of a victim but not available to strangers. Now moving to security model. The authors then define the security model upon which they use their assumption for this paper, and this involves three actors: a user, a server and an attacker. They assume that the user already has a registered password at server. Only the server knows the user's password, but the user's sister password might have leaks, and I will explain what is a sister password shortly. The server may be remote, such as a social media site, or local, such as a mobile device. The server enforces some security mechanisms, so A is the attacker is limited in their attacks, and these mechanisms might include suspicious login detection or a lockout, and the attacker knows some personal information about the user. The attacker might be a blackmailer or a curious friend or an internet troll or something. Now let's have a look at targeted online guessing scenario. So the authors break down 4 types of scenario for targeted online guessing. The first is the attacker might use public information and type 1 PII. For the second one, they might use public information and one sister password. For the third one, they use public information, a sister password, and type 1 PII. And in the fourth, they use all type of PII and a sister password. So type 1 and 2 PII and a sister password. And for each of these types of scenarios, they create an algorithm to which uses that the respective types of information, informing a curated list of password guesses. So to clarify, a sister password is a user password from a site other than the password is attacking. So the attackers only have at most one sister password. For example, if an attacker has a user's Yahoo password, while it's trying to guess the user's Gmail password, the Yahoo password would be considered the sister password in this scenario. Now the authors evaluate certain types of human behaviors and password creations, and they analyze popular passwords, password reuse, and passwords containing personal information. So now my other teammate will discuss the next topic.
Hello everyone, I'm Josh. I will continue with the further explanation. Let's talk about the password datasets that were considered for this paper. The authors have used a total of 10 password datasets available on the internet. 5 of them are from English sites such as RockQ, 000 Webhost, Yahoo, Rootkit, and Zato, while the other 5 are from the Chinese websites such as Dodonew, CSDN, 126, 12306, and Zarnu. Out of these password datasets, only 2 of them included the PII, that is personally identifiable information. Those sites were 12306, which is a train ticketing web service, and Rootkit, which is a hacker forum. This PII can be helpful in determining different aspects of the users in thinking in selecting a password based on their personal information. From these datasets, the author examined several behavior of password users among different sites on the internet. Let's have a look at those. The first behavior is of the popular passwords. Popular passwords are the most common passwords that are used by the user on different websites. For example, you know that when we are in a hurry and need to create a password for a least important website, we would simply create 1, 2, 3, 4, 5, 6 like passwords. Now these passwords are considered to be the popular passwords. It is observed that the Chinese passwords that are in the top list are simple digits, and the English passwords which are in the top list are meaningful or simple keyboard patterns. Love plays an important role here. Here, I love you and princess are among the top 10 list of 2 English sites, while 5201314 and Woini 1314, both of which sound as I love you forever and ever in Chinese, are among the top 10 list of 3 Chinese websites. The next behavior they observed was the password reuse across different websites. Generally, the fraction of shared passwords from the same language is substantially higher than that of the shared password from different languages. In addition, the fraction of shared password between any 2 services is less than 60% at any threshold k larger than 10, where k is the number of top passwords. This implies that both language and service plays an important role in shaping users' top popular passwords. RockQ and 000 Webhost share significantly fewer common passwords than other pairs do. We examine these 2 datasets and find that 99.29% of 000 Webhost passwords include both letters and digits, indicating that this site enforces a password creation policy that requires password to include both letters and digits. Well, these password policies across different websites can also play a significant role in password similarities. Third, they examine password reuse, that is the likelihood of a user to reuse passwords across sites. To evaluate these, the author did a Levenshtein distance similarity to compare non-identical passwords between sites, and this is just a measure of the similarity between 2 strings. And what they found was that Chinese users were far more likely to reuse the same password or similar password among sites than the English users. So as you can see, up to 30% of Chinese users' password among sites had similarity score of between 0.1 and 0.7. while for English site user password, about 20% remained between 0.1 and 0.7. Finally, they examined the behavior of creating passwords containing personal information, and they found that users often use their own personal information in building passwords. They found that users tended to use their full name in the passwords, and between 0.75 and 1.87% of users uses their full name. The birthday was very common among the Chinese users, that is about 1 to 5.26%, while the users of email in the password was very common among the English site users than the Chinese site users. Overall, such a variety of the PII increases the complexity for the password guessing mechanism. The authors believe that these PII-based datasets plays very significant role in making of the password guessing system. Now my teammates will explain the further topics in detail. Thank you everyone.
Hello everyone. To discuss further, author and his team created a TARGUS model framework for online password guessing. And here in the diagram we can see the architectural overview of the TARGUS model. So basically this model is divided in 3 phases. The first one is preparing, second one is the training, and third one is guessing. In the preparing phase, attacker tries to get all the personally identifiable information using the different approaches such as crawling, social engineering, or using the leaked online password datasets, or exploring the site policies of the different websites. And later on, this personally identifiable informations are used in training phase to create the different types of TARGUS models. And in the guessing phase, using this TARGUS model, personalized prioritized password guess lists were created. And this list were used later on to attempt to log in on the victim's account. So this is a model framework for the TARGUS model. Here we can see that TARGUS 1 model uses the probabilistic context-free grammar algorithm, which is very popular for online password guessing. And this algorithm breaks password into the different segments such as letter, digit, and symbols. For the example, we can see that if the password is w@1314, when the PCFG algorithm is applied, it will break down into segments such as for the letter, it will show the it will denote the length as well along with the password, and after that it will denote the symbol and the digits. And to create the efficient model, one more approach was added, which is a type-based personally identifiable information, which was used to label the password, denoting the structure base. So this model, this PII includes labeling the password based on the name, birthday, account name, email prefix, phone number, and identification number, such as social insurance number. So here to see how the TARGUS 1 model was trained. First it was like the passwords were broken down into the personally identifiable text, which is also known as a base structure, and PCFG segments. And later on, based on that passing, the probability was created for the base structure and PCFG segments. And for using that probabilities, a list of password was created. Here to explain in detail about the TARGUS 1 training model. For example, we have a data set of the password, and for the password, different types of password, different types of base structures were created by the author. Suppose here's the password says Wang 1982. So for that, the base structure would be N3B5. N3 denotes the last name of the password, which is Wang, and B5 denotes the birth year, which is 1982. Similarly, different base structures were created for the different types of passwords. And here in the base structure 4, we can see that PCFG algorithm was applied, which did break down the passwords into the letter, symbol, and digit, along with showing its length. And later on, for this base structures, probability was calculated out of the 5-base structure. So for example, for the N3B5, the probability would be 2 out of 5, as the in 5-base structure, for the password, different passwords, it was used 2 times N3B5, which is for the base structure 1 and base structure 3. So the probability would be 2 out of 5. And similarly, the probability was calculated for the different base structures. Later on, these probabilities were used to guess the password for the different types of users and create a different types of passwords for that particular users. For example, a user name is James Brown and his birth date is March 1, 1980. And if we consider the probability for the base structure N3B5, the probability is higher. So first it will consider that structure, and based on that, it will create a password Brown 1980, where the Brown is the last name of the user and 1980 is the birth date, which B5 denotes. So all the password guessing lists were created using this kind of probability structure. Some data facts about the Targus model. So 12,306 data set were used for the Targus 1 model, and that 50% of the data were used for the training and 50% data were used for the testing, and outcomes were really stunning when it comes to the comparing its counter password guessing PCFG system, trolling, and other algorithms which works on the similar concept. Here in the diagram, which we can also see that Targus 1 efficiency for guessing the password is really high as compared to the other algorithms, even as compared to the other Targus variants, as the Targus 1 model does the password guessing for the using the 6 types of personally identifiable information. To discuss further about the Targus 2 model, it aims to predict the user password from the sister password along with using the public information. Here are some challenges, such as the limited number of attempts are allowed as it does the online password guessing. Apart from this, for the password, which is not in the data set, it do the 6 to 7 type of transformation rules to create the different types of password on the given password. And the trained data sets were created based on the target system password policy and sister password system policy. To explain the training workflow, for the example, 2 data sets were tried to create, such as and later on each password from the both data sets were compared. If the both password are not in the data list, then it goes to the 6 structure level rules, where the insertion, deletion, capitalization, substring movement, and reverse count types of structure level operations perform. And if it's the same, then the identical passwords were removed, and later on for the unique passwords, it was checked like whether the password belongs to the top 10 list or not. If it belongs to that, the password is incremented to the 1, which we can see in the figure 10 and figure 11. Some data facts about the Targus 2 model and outcome. It was tested on the Dodo new data set, and it was compared with the DAS model, which is also work on the similar concept of guessing password using the sister password. And as far as when it comes to the efficiency, Targus 2 model showed that 20.19% efficiency for guessing password successfully as compared to the DAS, where the efficiency was 8.98% observed. And this efficiencies were calculated by considering that sites are allowing to guess the hundreds attempt. Thank you.
Hello everyone, I'm Vinay. Here I'm going to start with Target 3. It is an algorithm which uses both one register password and one type 1 PII. This is basically a combination of Targets 1 and 2. It was trained in the same way as Targets 2. It builds on Targets 2 by adding PII based tags. So this also outperformed us by an even greater margin, achieving a success rate of about 23.48%, whereas TAS only achieved a success rate of about 9%. In the given figure, we can see the comparison of all the algorithms. Next is about Targets 4. It uses all three types of available information, one register password, and both types 1 and 2 PII. It was able to achieve a success rate that was higher than any of other Targets algorithms. Authors have developed Bayesian theory model for password guessing. It achieves a success rate of about 24.51%, and it marginally outperforms Targets 3. Targets 4 achieves improvements over Targets 3 by 4.38%. Coming to evaluation, in total they evaluated 9 different algorithms: Markov, probabilistic context-free grammar, crawling optimal, DAS, personal PCFG, and Targets 1 to 4. Given 100 guesses, Targets 1 outperformed its counterpart personal PCFG by about 84%. Targets 2 outperformed its counterpart DAS algorithm by about 111%. Targets 3 and Targets 4 achieves a success rate of 73.09 for Chinese product passwords. That means given 100 guesses, it was able to achieve guess Chinese site passwords for almost 73%. Targets 4 achieved a very high rate of success. Here are some graphs to illustrate these evaluations. The conclusions that are drawn from this are: targeted online guessing is much more damaging and has much more greater than threat than crawling guessing. An online guessing attacker can gain advantages by exploiting various types of user personal information, including passwords and common PII. With the current security mechanisms, it would be largely ineffective against online guessing. And in here, authors have confirmed that targeted online guessing is a much more significant threat. Thank you.